Okay, question 3, basically in regards to our nuclear factor stack for basically taken from 2010's version, has a table, and the very first question actually shows you the sample of an iodine 128, and it varies with time. So we've actually got our time on our X in our first column and the activity, so the average disintegrations per second, and obviously that's value. Very first one is plot the graph of activity versus time. So very quick table in Excel, and that's actually being graphed. Now the thing that we need to look at here is we've actually got our blue points, which is the actual dot points off our graph data, and then we've actually just got a polynomial function going down there. Now that there is our graph. That is the plot of graph of activity versus time. So that there is all we needed to actually show. For question B, from the graph, find the time taken for this activity to drop from 60 to 30 disintegrations a second. So that's actually going through from 60 to 30. What we want to do to drop from here to 30 seconds. So again, I'm just going to go through, and now I'm just using these boxes just because it's easier to show because I don't have a ruler with me. And you can actually have a look at those two values, and it's roughly around the 8 mark there and about 32. So we're looking around 25. So there is about 25. So if we actually go back to here, that's about 25. And obviously it's across minutes, so it'll be 25 minutes. Now we're going to do the same thing for 40 to 20 disintegrations a second. So we'll go back to our graph, delete those off, and again I'm just going to use a rectangle. So from the 40, roughly that's where it's colliding, to 20, which is just here. And we're probably looking at about 23, 24, and about 44. So again, we're looking around, well, you could even stretch it out to be 22 and 45. So you're looking around the 25 mark again. These two numbers, when you're actually looking back at your SAC, will actually be approximately the same for both. Okay. Now, what is the half-life of iodine? Now, with half-life, you can actually jump onto a number of different resources, but you can actually see that this disintegrations per second is actually going from 60 to 30, and a half-life is how long it lasts for, but half. So half of 60 is 30, and it lasts for 25 minutes. Half of 40 is 20, so it lasts for about 25 minutes. Now, if you have a bit of discrepancy between these two numbers when you measure it a little bit more accurately, obviously you would take the average, but in this case, I've made sure that they equal the same. But if they do actually change, make sure you actually look at the fact that you do need to take the average of those two numbers. The average of two 25s is 25. So the half-life of iodine 128 is 25 minutes. So how long would the activity of a sample of iodine 128 take to drop from 300 to 75 disintegrations a second? Okay, so this is where we can actually get into a little bit of writing. So the very first thing that we're going to do is 300. Now I know that I've that number there. Half of 300 is 150. Half that's 75. And we can keep on going, but it's actually asking how long does it take to go from 300 all the way down to 75. And we know that one half-life is equal to about 25 minutes. Of that 25 minutes, we can see that 300 to 150 is half of that number, so that is one half-life. Then we can say 150 to 75 is a second half-life. Now, we can actually do a little bit of addition, so we've got 25 minutes here, and 25 minutes here. So how long does it take to go from our 300 all the way down to 75? Well, 25 plus 25 equals 50. As for our final question, I will quickly go through at the start of the class in regards to how to do those, so they are fresh in your memory. They are within your notes, but this is to make sure that I can tell the difference between who has been studying and who hasn't been. If you have any further questions, just ask on Edmodo.